Okay, well, we're very honored to speak with Ian Lipkin. Um, he's been known throughout the world as a master virus hunter, and he's developed numerous innovative techniques to find and diagnose viruses. He's known he has trained many people in his detection techniques. He is on call to governments around the world when new pathogens pop up. Um, he's also involved in autism uh, and various other, as well as other infectious diseases. For our purposes, though, what we're most interested in is that Ian Lipkin has been one of the first people to really advocate for MECFS on a high level. He's been interested in it for decades. He played a key role in the unraveling what happened with XMRV. And he's run one of the, well, now one of the two remaining NIH research centers for MECFS. Um, he's on his uh, second grant with that. That's just started. And so it's just great. He's probably the one of the foremost people to publicly advocate for MECFS at the NIH and elsewhere. And we have just really appreciated his support. Back in the day, we really didn't have researchers of his caliber investigating MECFS. So it's really a pleasure and to be able to talk to you today.
Well, thanks very much, Court. You make me sound like a jack of all trades, and hopefully I've been able to be helpful with some of those. They're not as different as they might seem.
Hmm?
All of these things that I've been engaged in have been focused on trying to understand why people are sick, how they get sick. And when I was finishing medical school, everyone was becoming very interested in genetics and threw out the whole notion that the environment was important. And now it's become increasingly evident that there's an interplay, right, between what you see and how you respond, and that it's an unholy collaboration between toxins of various types in the environment, whether they be infections or chemicals, what have you, interacting with a susceptible immune system and other genetic, aspects of who we are that result in disease. And you're right, my field of expertise really has been, in detecting and implicating infectious agents. And I've been particularly interested, over the past, God, I would say 15 years in moving away from acute illnesses like pneumonia and encephalitis, where I think I can help people develop the skills they need to do that work on their own and to focus on the ones that are, I think, more challenging and important and neglected, like MECFS and autism. And as long as you started with autism, you mentioned that before MECFS, I was involved in helping to direct a large birth cohort in Norway with Camilla Stoltenberg, the older sister of Jens Stoltenberg, who was, was basically director of NATO until
Oh,
recently. Very accomplished
oh.
family. Anyway,
Mhm.
we began looking at factors prenatally that were important in predicting who would subsequently get a diagnosis of autism. And we found that women who had histories of infections and
Mm,
elevated levels of cytokines
mm.
were at a markedly increased risk of having children who ultimately received a diagnosis of autism. So
Wow.
there are all sorts of interesting segues to trying to understand how we respond to infectious diseases. When I was still in California, so this would have been the mid 90s, there was a Japanese group that claimed that born disease virus, a virus that we discovered using molecular methods, was the cause of ME/CFS. So then the director of the viral and rickettsial diseases branch there, Brian Mahi, asked me to look into this for them. And I went to Sweden and I spent a lot of time getting samples, and we found no evidence that this virus that we discovered was important in this disease. But we did find something that people have forgotten that was published, I think, in 1999, and that was that people with ME/CFS had elevated antibody titers to all sorts of things that are not even found in nature. So there was an immune dysregulation. So think about this. This is the time when people were talking about psychological abnormalities, malingering, and so on. But we had in 77% of the patients who had a diagnosis of ME/CFS had abnormal antibody profiles. And it's buried in the second to last paragraph of the paper. But it was there, and we stood by it. And look at us now, more and more data all the time confirming this. And this is sort of what I've seen about this field. People with ME/CFS have not had a fair shake. And this goes back decades.
Yes.
So,
Yes.
so when we did the XMRV work, and I went out to the Whittemore Peterson Institute, and I saw what they were doing, and there were problems with their assays, and they published this work suggesting that they'd found a virus that was important. And there was a companion paper came out roughly at the same time from another group at the clinical center at NIH and the FDA, saying that there was another virus, which was retrovirus, that was implicated. It sort of piqued my interest again and allowed us to get some support to do further work. So as we began doing this, and because it was concerned that this was a potential threat to the blood supply, the very highest levels of NIH were involved. So it was Francis Collins. So this is back in 2010. Francis Collins, who was then the director, Harold Varmus, Nobel laureate, head of NCI, and Tony Fauci, director of NIAID. And all three of them were persuaded that this was something that deserved a deeper look. And then there was a father of a young man who was at Harvard, who had gone from a 4.0 to a worse grade point average. He clearly had ME/CFS. He'd seen Tony Komaroff, whose name I'm sure you know, good friend of mine, and somebody now deceased named Scott Hammer. And we examined his peripheral white blood cells. We found very high levels of Epstein-Barr virus. He was treated accordingly, and he went back up to the top of his class, and is now taking his business. So this individual, Glenn Hutchins, decided to form something called the Chronic Fatigue Initiative, which was the first really substantive money that came into this field. And it allowed us to support, Nancy Klimas and Tony Komaroff and Sue Levine and Jose Montoya and, a whole group of people who began collecting samples that people would then use to address various possible mechanisms. So we helped them do that. And very rapidly, it became clear that there were all these abnormalities in immune responses and in cellular metabolism, and then abnormalities in GI microflora, which we can talk about, which I think are interesting.
Mm-hmm.
And, I wouldn't say we're there yet, but we have now, I think, some very plausible models that suggest that we can start clinical trials very soon. we need to find a way to parse patients into different groups, because I don't think everybody has the same underlying problems. Some people vary in different ways. Some people are going to be more responsive to one therapy or another. But we now have the tools to tease that apart and to deliver, the medicines that people deserve. I can't tell you, it's so much more gratifying for me personally, because I've met these people, so many of them, through the years, who've been suffering without any hope, to tell them that, it's around the corner.
Hmm. Hmm.
Now there's some challenges which I'll tell you about. Um, you mentioned that we're one of two centers. Well, we haven't got any money. So
Oh
yeah,
my gosh.
yes, we are approved to be a center. I don't know, where do you want to go with this conversation? We can talk about that, or we can talk about the science, or both, in whatever order you like.
Well, I would like to learn about the funding. I know Columbia was caught in the crosshairs. Is can you hear me okay?
I can hear you quite well.
Okay, I just got to notice. I know that, Columbia is having trouble with the Trump administration, and I remember your funding was cut, but that was what, 5 months ago, 4, 5, 6 months ago? Is it you still don't have any funding?
Not a whit,
Not
nothing.
a what does
So
that do
that
to your program?
so that's it's a very difficult question to answer.
Hmm.
It's a painful question to answer. So um, we had three projects. The first one, that I co-led with Tony Komarov, we called the Good Day, Bad Day Project. The idea there was that there are days when people are, worse, and days when people feel better. And if we could rapidly collect saliva, blood, urine, other things that we could then give us some insight into what was going wrong. And then we could look 2 or 3 weeks later and we could find something different in the pattern again. We would be able to say, well, maybe we haven't gotten at the cause, but we've gotten at the things that contribute to the disability or the
Yeah.
improvement. And that would give us clues for treatment and for prevention. And I can talk a little bit more about that, but let me first give you the other two. The second one was a collaboration with the University of Edinburgh.
Hmm.
Chris
Hmm.
Ponting, who runs a large program out of the UK Biobank, has been using a method called GWAS,
Yes.
genome-wide association studies, right, to do detailed analyses of thousands of people with ME/CFS. We were going to do a parallel study in the US. We were going to combine the two data sets and find genetic abnormalities,
Hmm.
genetic susceptibility markers that would allow us to predict who is at risk and who is at lower risk of developing ME/CFS as a function of what they might confront in everyday. And the third was to use a very interesting resource developed by the Department of Defense. Once a year, at least, blood is collected and stored as part of an HIV surveillance program in the Department of Defense. And there are millions of samples that have been stored for years. And if you have a good research question and a colleague in the Department of Defense who supports your program, your project, you can get access to these materials. So you can get plasma or serum from people before they develop ME/CFS and after they develop ME/CFS, and you can see whether or not there's been some sort of interval exposure that resulted in triggering the disease. It's more complicated than that because you have to find these people, and the diagnostic categories were not as clean for ME/CFS diagnosis going back 10 or 20 years. But we found a way to do it using, AI and a number of other tools. So we could identify people with ME/CFS and we could test those hypotheses. So we,
And you
you know,
could assess different durations, which was that was a major thing in one of your papers.
was, and I want to get into all of that science. And I don't want to ramble because it may get confusing, but you asked about the funding and I think it's important to
Yeah.
talk. So, Columbia had the majority of its funding terminated,
Right.
for a variety of reasons. I'm not a politician and I don't want to get into that, but it's hard for me to see how penalizing people with ME/CFS is going to make America great again. It's not, obviously. And originally we had 3 of these centers, one at Jackson Labs, one at Cornell, one here. Ours was a little larger than the other 2, not in terms of money, but in terms of the number of people outside, because we didn't keep it local. So we had people doing metabolomic work at Davis. We had Tony Komaroff at Harvard. We had, a number of other people who collaborated with us around the world who were participants. So the money didn't go as far as it should have gone. But the total cost that we had for these grants, each of these 3 centers, was $2 million. And of that, there was indirect costs, which is it's not something that the university tax on arbitrarily. It's what it costs to do the research. You got to pay for utilities, security, the committees that make sure that your books are accurate, the libraries work, the IT works. All of that is very, very expensive. Anyway, the amount you had to do the work was $1.2 million a year at each of these centers. And that was 7 years ago that they first put that together.
Right.
Little more. So the second round, it was still the same budget, still the same $1.2 million. But we've had inflation, for example,
Lots of inflation.
over that period of time. So you don't really have $1.2 million in terms of the original allocation. And of course, they cut down from 3 centers to 2. And then when they cut us out, it was basically 1 center at Cornell that was allowed to keep working. So what we've been doing is running on, a little bit of money that, so we're eager to dig in and get the work done. But we've been stymied now for almost a year, while we got everything regulated. And then, of course, everything sort of, disappeared, when we got this notice in October that our grant was terminated. But it was curious because the NIH didn't get a notification that the grant was terminated. Our Sponsored Projects Administration did. So we were not allowed to spend any money. They kept wondering why the spigot had been turned off. And we still don't know. So last week, we were told one day that the spigot was turned back on and there was jubilation in the patient community and amongst the scientists. We're finally going to get to work. We're going to solve these problems. And then literally within hours, we were told there was no reprieve. So I got once a day or so, I get a note saying, the grants are back on, but they're never confirmed. So I frankly do not know when or if we will ever be funded again.
My goodness.
Yeah. So last week I had a conversation organized by a physician who was taking care of a family member of a very wealthy individual who said he wanted to fund, the whole program. And I thought to myself, there's light at the end of the tunnel. It's all going to work. And then I had a conversation with an individual who said to me, Well, I think you can compress all this into 1 year. I said, this is a 5-year program. Takes a while to collect samples, to do the work, everything else. And so I don't know. I'm hoping that somebody somewhere maybe watches your podcast. Will see fit to, to find some way to help get this stuff going. I'm not at this stage, I'm 73 years old. I'm doing this because I told people that I was going to do it. I believe in it. And, I know 3 people with MECFS, who've killed themselves.
Yeah.
And young, vibrant people.
Oh,
And that's what we're in this for.
yeah.
Because it's not a wealthy population. I'm not looking to do, and as you say, I've already had a career. I'm doing this that's what this is about. Anyway, so let's talk about the science, because that's really what's exciting.
Well, it
Um,
seemed, reading about the funding cut, it seemed like you were really on the cusp of something. There was an article in the media outlet that said you were talking to pharmaceutical companies and
oh yeah, so
yeah.
look, Court, there's so much hope right now.
Uh-huh.
We can finally get somewhere with this. So
Oh, can I just ask you about
anything.
Colombia? I mean, is this just this is happening all over Colombia. This is I mean, the grants have not been restored to anybody in Colombia. Is that to your knowledge? Is that true
Well,
or
that's not accurate.
okay.
It's mostly accurate.
Okay.
There are exceptions. So there's a guy here who works on our center who studies tick-borne diseases
Hmm.
like Lyme. His grants have continued unimpeded.
Mm.
And there are other people I know. So look, there are a couple of different ways in which grants have been terminated. If you're working on a grant where the focus is on, making, new viruses, what's called gain of function
Right.
experiments, so forth, um, that's one group that's excluded. We don't do that. I did gain of function early on with West now, but that's like 2000, 25 years ago. So I'm not doing any gain of function work. So that doesn't pertain. There are people who do work on, certain kinds of underrepresented populations, or
Right.
that
Right.
because of sexual orientation or because of race or what have you. Those people are another pile. They push those away as well.
Hmm.
The vast majority of the grants that have been terminated don't have neither of those pertains. And I'm not casting any value judgment on whether you should or shouldn't do that research. That I'm not saying, simply saying the vast majority of grants were canceled because of accusations of anti-Semitism at
Hmm.
Columbia University,
Right. Right.
which and that decision was made at the institutional level without even looking at the grants.
Yeah.
And in some instances, there's an official termination letter. For example, I do work on Gulf War illness as well, a related condition. And in my view, you send somebody to fight someplace, they risk their lives, they come back ill, you owe them. So, I started working Gulf War illness because it was overlap with MECFS, and many of these people actually met criteria for MECFS. So it wasn't a stretch. It made sense to kind of augment, the database so that you get insights that would help both groups of patients. That one was terminated with a letter that came from the Veterans Administration. No
Oh,
question.
wow. And
But
that's
but the NIH MECFS one we haven't actually heard that we were terminated by NIH. But someone somewhere told the administration that we were terminated. So I don't, people ask me, show me your termination notice. I say, I can't, I don't have one. All I have is the notice from Sponsored Projects Columbia telling me that I'm terminated. But if you go into the NIH website and you look up our grant, it's still listed as active, but on hold.
Oh, it's so chaotic.
But the functional, the functional impact of that is equivalent to being canceled, except that it means that at any moment they can turn it back on without any delay. So that's
It's kind of
better. That's
that's
better.
that's better. Yes, yes.
You know,
It's kind of Kafkaesque, isn't it?
possible.
You just don't know
So,
what's going on.
well,
But that's great.
here, if
Yeah.
anybody on your, anybody listening has any influence, on how these decisions made, please get that turned back on because we are so eager to get back to work for you. Anyway, so let me tell you what's new and cool and intriguing and so forth. So we talked a little bit about the immunological abnormalities, which goes back to us finding these in the Swedish ME/CFS patients back in the late 1990s. And as you know, there are many people who report an infectious sort of prodrome that may proceed, immediately or by months, the onset of ME/CFS. And then when we began seeing patients with long COVID, that gave additional support to the idea that an infection, clearly, documented infection, could trigger disease. We've looked in a large number of samples, collected not prospectively, but collected prospectively, for evidence of infection with viruses and bacteria and fungi. We did this work with Montoya, we did it with the Chronic Fatigue Initiative, and we did it with NIH. And in samples that are collected when people get into a regular clinic visit, no reference to being specifically sick in association with that visit. In fact, you may be selecting for them feeling better because they can get into the clinic, right, and be seen. Didn't find anything using that approach. Using the most sensitive tools, the ones that I built for biodefense and emerging infections over a period of decades, starting with various PCR assays, sequencing, and everything else. We figured if anybody's going to find it, we're 1,000-fold more sensitive than anybody else. We should find it. We didn't. That doesn't mean there isn't an infectious trigger. It could mean you could have a hit and run phenomenon, right?
Yes, yes.
So we, which is certainly plausible. So we then shifted to serology, looking for antibodies, changes in antibodies. And we developed a unique method that we've used, for Zika and pregnancy for women who might have kids who are microcephalic, used it for dengue infections, a wide range of different applications, tick-borne diseases. So we can find not only changes in the amount of antibody, what we call the titer, right, an antibody to an infectious agent, but antibodies to a specific part of the agent that is only expressed, only able to trigger immune response with a reactivation, like you see with herpes viruses, for example. So instead of looking at reactivity to the whole virus, we can actually look at very small portions of the viral proteome. And so we're in a position now where we can go in, and we have some preliminary data that suggests that people with ME/CFS who have an exacerbation of disease have changes in their saliva, in the amount of virus that's present. And if you look weeks downstream, you find that they have antibody titers that come up directed against specific portions of that virus. So now you have a 1-2 punch. You found it, and you found the antibody response to it. Well, that group of patients clearly is a group of patients that would benefit from some sort of viral suppression therapy. I'm not saying this works for everybody. I'm saying that's clearly an example of where having a biomarker could get you to the point you say, look, this percentage of these patients who have this biomarker are going to respond. It's no different than treating high blood pressure. Some people respond to, this drug or that drug, what have you. You need to understand what's wrong. The other thing is there are a group of patients who have persistent infections who respond to Ampligen. They just do, regardless of the fact that some people don't believe it. I've seen it. It's real. Dan Peterson, who's been sort of pioneer in this area, has shown, unequivocally that there are certain markers that he can identify which allow him to say, this is somebody who's going to respond, and this is somebody who won't. Now, the problem with Ampligen is it's really expensive and it's difficult to administer. But if you were convinced, right, that this was real, and with a proper controlled trial, you would then get people who would say, yes, we want to, invest in this. Just like right now with these, GLP antagonists, right now it's, injections, we start off with injections on a regular basis. Then it, the length of time required, it became longer, between injections. And now we're getting to where we're going to have oral drugs, right? So the same thing might pertain here. I wouldn't be surprised if we couldn't get an oral version or an inhaled version or something else of Ampligen. But anything that turns on the innate immune system. Now, how does Ampligen work? So, Donald Trump likes to talk about the weave, right? Where he rambles around. And there is a point to this weave. It all does come back to the immune system. So Ampligen is something called poly-IC. Poly-IC stimulates the innate immune system and basically kicks out the virus, prevents it from replicating. This is not all that different with the way we used to treat hepatitis C. When I was first training with, in medicine, we used to give people ribavirin, which caused the virus to mutate, and interferon. And we could cure it. Now, people got really sick on this cocktail, but it was effective. And now we have a drug that really works without those side effects. So I think that we're going to get to that point once we identify the triggers of ME/CFS, so we can give people specific drugs that will not be toxic. That's what I'm really excited about. We got 3 to 4 million people with ME/CFS in the US alone.
Right.
And, and they've, and they would all benefit from this. And I think that probably based on COVID, many of them are going to have a similar mechanism. And if it works, it's going to work for that. Not all things are the same way. Now, what did we find in these sort of cross-sectional analyses of samples during the first funding cycle of NIH? We did this work on the microbiome, which I'm sure you remember. And what was fascinating there was that people with ME/CFS, not everyone, but a large percentage of those individuals had abnormalities in the types of bacteria. Let me just have something to drink here for a second. In their feces. And when we characterized those bacteria, we found that they did not make a very short chain fatty acid called butyrate.
Right.
Butyrate is extremely important for several reasons. One is it modulates the immune system. The other thing it does is to maintain the integrity of colonic epithelial cells, which means that whatever's inside the GI tract is more likely to stay there as opposed to going into the systemic circulation, causing, wreaking havoc. This suggested to us that there is a group of people who have this abnormality who will benefit from probiotics and prebiotics. I'm not going to say it's going to work for everybody.
Mm.
My view, what you should do when you have a patient comes in with ME/CFS, you want to have an efficient panel so you can rapidly decide they fit into this category or that category, next category. And the likely way the best way to treat you is initially was with this, and with this, and with this. And somebody else who may follow that patient may have a different profile, and they may require something different. So we need, we still at the point where we're doing research and sorting out, what the causes are. But I think we're very, very close to being able to have precise treatment for people with ME/CFS, at least a large number of people with ME/CFS. And we will understand what triggers it, and we will understand how to prevent it. And it's complicated because some people, we find metabolic lesions that explain their cognitive problems, brain fog, as well as fatigue. Now, I don't think that you can repair mitochondria overnight. If you can eliminate what's causing the damage and allow the natural repair to occur, you can see improvement. And I've seen this in some patients who've been treated with Ampligen and so forth. One woman, I was very close to because I was working with her family, and Dan Peterson was, knows this individual as well. The first time I met her, she was in a dark room, couldn't tolerate any sound, any light, any movement. And she's now able to sit outside. Is she walking? Not very well. But she's able to go outside and tolerate full sunlight and everything else. So that's an improvement. I think we can get her better still. And that's what we want to do.
These so you're able to, or you're close to being able to identify specific pathogens through this antibody work that are triggering the illness in different people. Did I get that right?
That's what we think we're going to find. But as we were just starting this work, the funding ran.
Yeah,
So
yeah.
very small numbers. I mean, it's like I got five patients. I have 3 patients where we've looked at saliva and we found out that, at the time that there was a major episode, the titers of EBV went up, the amount of EBV in the saliva went up. And if we look 2 weeks later, HHV6 came up and EBV began to drop. And so at this point, I'm very reluctant to tell you, we've solved it. All I know is, there's enough encouragement in the data to warrant looking deeper. And the sooner we can get to it, the faster we can say, this group of people has this problem, this group of people has that problem. We need a clinical trial of naltrexone, Ampligen, dietary modifications, stellate ganglion blocks. I don't know. All of these different groups have to be broken apart,
Right.
and worked on discreetly. So I think we can get there. I really do. And as recently as a couple of months ago, we were meeting regularly, a group of us, leading, clinical and basic researchers, trying to figure out how, where we would prioritize the first efforts in trying to get clinical trials bill. And we
Oh,
tried at one point to piggyback onto the long COVID trials. Because
yeah.
in contrast to MECFS, they got $1 billion.
Right,
You
right.
know,
This
MECFS,
was this within the NIH that you were doing this?
yeah, we were meeting on a regular basis trying to figure out, what should be prioritized in long COVID. And the argument that I was making is, look, you need a control group, right?
Mm,
People who are normal, or people who've had MU, people who've had, SARS-CoV-2 infections, but who had an MECFS. Can we just include 100 of those patients
right.
in each clinical trial? You know, and then if in fact they improved and long COVID patients improved, that's great. And if only the MECFS patients improved, also great, But to finally get a clinical trial going for MECFS would be terrific. And I know we can get there, but we need investment. So one of the advantages to being in this field of science so long is that I've seen what happens when someone steps up to the plate. It's typically somebody who's very wealthy, who has patients who had problems, as a patient and family. So
Yeah.
I saw this with autism. I saw it with Parkinson's disease. I've seen it with MS. And if you get this kind of unrestricted support that allows you to move quickly, you can have a huge impact. So in the autism world, it was the National Alliance for Autism Research and the Cure Autism Now Foundation. Then it was Solve, not Solve, it was getting the name for it right now. Then there was the Simons Foundation, also autism. Then there were these Parkinson's groups that came together. But patients with MECFS have never been able to successfully advocate for themselves.
Right.
This is because they're so ill.
Yes, 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 yes. It is with regard to the antibody stuff, is this like new technology that's allowing you to kind of peer deeper into what's going on? Is that part of why
That's where
you're
we start.
excited about it?
So yes, so in the old days, you know, 10 years ago, people would look at two different types of antibodies, IgM and IgG.
Hmm.
Well, the IgM antibodies are high, that's associated with recent infection. IgG is higher, that's more likely to be associated with, a recovery from infection or a chronic infection. And nobody was able to really look at relationships between closely related viruses. I mean, there's, there's scores of different enteroviruses. And if you have an enterovirus antibody, you don't know if it's to this enterovirus, that enterovirus, or discrete assays, you can differentiate the two. So this was very important when we were looking a few years ago at kids who had this paralytic disease, look like polio, called acute flaccid myelitis.
Right.
And by using these very discrete antibody profiles, we were able to say that they were infected with an enterovirus called enterovirus D68. You can't make a vaccine for all enteroviruses, but you could for a specific type of enterovirus. The same thing is going to be important, I think, with MECFS. So with the tools we now have, we can not only say, look, this person has seen EBV, because almost everybody on this call has seen EBV. But if I can tell you that you have an immune response to a portion of that virus that is only expressed with a reactivation, now you're getting something. You can really say there's been something that's happened that's different. And if you have data collected 2-3 weeks earlier that shows that they have virus in saliva, putting those two together, you make a very compelling case. So our project one does exactly that. A patient has an app. I'm feeling well today. This is good. This is bad, what have you. When it hits some threshold, that prompt, which is read by a coordinator, says, I'm going to go out and meet this person, see how they're doing, collect samples, bring them back to the lab. We then look at the metabolites, proteins, nucleic acids, antibodies, and then 3 weeks later, coordinator goes back out for a second set of collections, and we compare what was in the first set and the second set. So each individual is his or her own control,
Right. Right.
as opposed to the way we used to do it, right? But you cannot get somebody who's got an exacerbation of ME/CFS into a clinic to be seen. They can't even get out of the house. That's why this first project was so important. We had the resources to send someone out to collect these materials and talk to these people and get the data. And the third one, as I say, is a sort of from year to year sort of situation where we look at what somebody might have happened to somebody early on that subsequently resulted in disease. And all three of these things went through very rigorous peer review. So it's not like they were just, accepted because they came in, from what I'm trying to say, a lot of people wanted to do studies.
Yes. Yes. Yes.
And these were considered notorious by our colleagues, right, in peer review. So there's no reason for them not to be funded.
Well, it sure sounds like you could get great, really good diagnostic signatures. You're taking all this different data. You have immune data, you have metabolic data, uh,
Proteomic data,
proteomic data.
transcriptomic data.
Uh-huh.
One of the most exciting things we had, which we're trying to get published right now, which I'll tell you about, which I think provides really interesting and important clues. We had people exercise, which was really difficult. So we also did this with gulfur illness. People exercise. We collected blood before and after exercise, measured a variety of different kinds of things. And we took peripheral blood mononuclear cells, white cells, and we put them into little chambers, incubation chambers, where they were exposed to various triggers of innate immunity that looked like a gram-positive bacterium, a gram-negative bacterium, a virus, or a fungus. And we collected the supernate, the material that came off these cells at various intervals. And we looked at it using metabolomics, immunological measures, cytokines, all these other things, and some transcriptomic data as well. And what we found was the patients with ME/CFS had a much greater response to these immune stimuli, the stimuli immune system, than people who were considered healthy controls. The symptoms were more pronounced in women than in men, and more pronounced still in women over the age of 45 who had low levels of estrogens, consistent with menopause. So this mirrored what we see clinically. And we also found abnormalities in various metabolites associated with damage to mitochondria. So putting all this together, for the very first time, I had this new hypothesis, which was really cool, that tied back to what I mentioned earlier about the microbiome. So if you have a reduced threshold for triggering an innate immune response, you're going to feel sick all the time.
Yes.
Time you brush your teeth or have a bowel movement. If your mucosa in the gastrointestinal tract are permeable, then these compounds associated with bacteria, because basically your gut is filled with bacteria, cross into the blood and causes an immune response.
Yeah.
So it all sort of it's all sort of coming together in a very interesting way. And there are drugs that you can use to suppress innate immunity,
Yes.
right?
Yes.
Which I talked about at NIH 3 years ago. I still think, so it's, I am so encouraged. I am so eager. And anybody watching this podcast, and there's one person in particular, Ron, you know, don't give up hope. I really think we're almost there. It's just, I get these notes sometimes from people who say, I want to donate my body for your research. And I say, please don't, I just hang in there. We're almost there.
Well, it does seem like so many things are tying together. Your earlier paper where you found the immune exhaustion in the later duration patients, and now there's all this stuff on T cell exhaustion and an innate immune response, and maybe it's compensating for the T cells and the B cells and are unable to get their act together, and it really
And,
does seem that the metabolic problems and the mitochondria. Do you Yes, there really is.
well,
It really
it's
is very
very nice to
encouraging.
hear you say that, Kurt, because it means that somebody's actually read these papers. Because I keep reading these things and people say it's, this is a brand new finding, and all I got to say is, maybe, maybe not. Uh, I'm glad that people build on it, and the important thing is we find ways to make people feel better. Um,
Right.
but the story is coming together.
Yeah.
And,
Yeah.
if somebody came along and said to me, I want to do a Manhattan project,
Oh, yeah.
CFS, we could get this thing done in 2 years. I remember several years ago, I said, we talked about 5 years, but we didn't get the 5 years of support,
Yeah.
you know. So and you can't do this on a shoestring. This
I,
deserves the same amount of investment as heart disease or, or any other and I'm saying that as a guy with heart disease, you know, as anything else. These patients deserve better.
Agreed. Agreed. And it is a very exciting time. Well, it is good to hear that your funding has not been terminated. It's just kind of in limbo right now. And maybe somebody just needs to flip the switch somewhere.
If somebody knows how to get that switch flipped, they will have the undying gratitude of 3 million people in the
Yes.
US alone.
And
Anyway, I'm going to ask you a favor.
okay.
Um, and I'm not asking for me. My salary doesn't depend on this. I would really appreciate it if the development people at Columbia could send you some sort of a link. If people want to actually help solve this problem,
Hmm.
we can get donations. In the past, I remember when I was in San Francisco, there was a very generous donor, John Gunther, who helped us get going. John, we it wasn't Gunner, excuse me, it's John Gunn. Um, we need to keep going, and right now we can't. And people who would stay in this field, work in this field, we're having to let them go.
Yeah,
Got no
that's
way to pay them. So if I
that's
can get the development people, maybe you can stick a link in there somehow. Any amount of money would be helpful, truly. Um,
sure. What
because
about
we could,
there is a lot of interest in long COVID. What about the long COVID MECFS link and, getting people who are interested in solving both? I mean, do you see these diseases as being very closely linked together? Um,
Well, long COVID has, the linkage is more complicated than people think.
Hmm.
I mean, you've got people with structural damage, vascular damage,
Right, right,
lung damage, heart damage, and you've got to tease all that apart. That said, there are people who clearly have recovered, who then have long COVID, looks like ME/CFS. That group
right,
of individuals, I think, would be a great, augment or comparator group for looking at ME/CFS. I think it's important that we characterize people who had ME/CFS before 2020
hmm
because I
hmm
think it may or may not be the same. I think there are
right,
going to be similarities. I think we'll learn a lot, but I don't think that I can say that if we solve, long COVID, not that we're there, that that's going to be the answer necessarily for ME/CFS. That's why
right.
in the in these long COVID trials, we talked about having an ME/CFS control group, right? You have
Yes,
control groups anyway. Why not make it something that's relevant for understanding that disease? Because if you saw like in a Venn diagram, you have circles that overlap, you could probably find people who had overlap in symptoms that would tell you something about mechanism, and mechanism leads you to therapy,
right.
preventive as well as interventional therapy.
So that apparently didn't pan out. Do you know, is Recover interested in bringing in an MECFS cohort? In it, no, nothing
You're shaking my head because we've tried. I've written
yeah,
letter. I wrote to the director of NIH prior to Jay Bhattacharya. Um, our hands were tied. I mean, the money was allocated specifically for long COVID, and the people who work on long COVID don't want to, they're not the same people who work on ME/CFS.
right, right, right.
And so, and they're not, I hate to say this, but scientists are a slice of life. You know, they are, they get into issues of territoriality and so on. So they did not want to share.
Got it. Got it. Yeah. Yeah, that's how it seemed to have gone.
No, right.
Okay.
The whole thing could turn on a dime, and so I don't want to alienate anyone. Um, and I'd be delighted to participate in anything where I think we can, reduce the burden of disease for long COVID, for ME/CFS, and preferably both, as well as wellness. I think, talking a little bit just about Gulf wellness, we were working with very well-known people in that field in Madison, Wisconsin, and in Indiana. And we collected all of the samples. We'd run a lot of the data through all of our pipelines that were developed doing the work on ME/CFS. And we can't even write up the work
You
because
don't.
because it's terminated. So
Right.
I can't even do anything with the data. And I would have these discussions with people about it. So they said, well, it says here that you sent samples off for analysis. So why are you asking to be paid to do the analysis? And I said, well, what should have said, you should read that as saying is measurements were done here and there and the other place. But putting all that together, analyzing it, doing the bioinformatics, the biostatistics, making the models, forget that requires, work that you don't get from somebody to whom you send a sample. It's not like we're measuring glucose or potassium. It's very complicated. You've got thousands of things that you need to analyze, figure out. And then you hear from other people say, oh, just put it into an AI. Well,
It's just kind of astonishing to hear this because I
well,
mean the assessment, the writing up, all that it's a big part of a research project.
I had a conversation with one of these donors, potential donors, not any of the people I've mentioned, but this potential donor who wanted us to do all this work very, very rapidly. And he said, and so I don't understand what you do. What do you do? Sounds to me like everybody else does everything. I said, well, it's sort of like asking, somebody who conducts a symphony orchestra. You don't play an instrument. Why do we need you? I said, no, I guess you don't. You can just bring everybody in and let them play and hope that everybody stays on tune and in rhythm, right? That's
Right.
what we like to think that we have some modest contribution to how the thing comes together. Anyway,
Okay. Well, we'll definitely get that link, and let's hope that somebody shows up, or that the funding suddenly the sky clears, and all of a
well,
sudden the funding is there.
even if the funding came back, when I pointed out to you earlier, it's
Yeah,
the same funding that was allocated 7 years ago. So
yeah,
funding is really needed. And I
yes,
promise we will be good stewards of any investment that's made. Anyway, let's not let it be another 15 years before we see each other again, Corey.
definitely not, definitely not. Okay, all right. Well, thank you so much. And it's frustrating what's going on, but I'm also left really excited about the science and gratified that we're
It's
getting so much
really,
closer.
we're
Yeah.
so much closer. So you're
Yeah.
in Flagstaff now, right now, right?
Yes, right now. Yeah, yeah,
I
yeah,
want
yeah.
to show you something amazing. Don't go away quite yet.
Okay.
Hmm. I have here something
My
that is
gosh.
very amazing. Have you ever
Wow.
seen anything like that?
No, I haven't. No, it's
So many years ago, I was in the Southwest and I was going through an Indian trading post,
yeah.
run, and as they were called, I don't mean anything pejorative by using that term. Anyway, everybody was interested in buying pottery. And I looked on top of a shelf, sort of, way in the back, and I said, is that for sale? And the guy said, yeah, it's nobody's interested in anything like that. I said, well, I am. So I bought it, and at some point I'm going to give it to the museum, but I want to show it to you because it is a magic stick. It is a medicine stick. So
Uh,
there's an antler from a deer.
uh-huh.
These are hand beaten copper bells, beads, and there's beadwork all the way around this, muskrat fur,
Wow.
and the tail of a horse.
Wow.
So my objective before this is all done, my time on this planet, is to take the modern equivalent of a medicine stick and to solve this problem. Until
There you
then, all I can do is this.
That's right. Shake the stick, you know.
All right.
Let's hope for some good medicine
All
uh
right. You got it.
coming our way soon.
Take care. Yeah. Bye bye.
Okay. Thank you very much. Bye.